Hello everyone, this is tutorial class on lecture 10, and in this tutorial class I am going to talk about some problems from center of mass. So you see problem number 1. In this problem we have 3 particles of different masses, and these particles are placed on a two-dimensional coordinate system as we have seen here, uh, the right side diagram. And these 3 particles form a equilateral triangle of edge length 140 centimeter. We have to find out uh, the center of mass for the system of 3 particles. So here, for our convenience, we place these 3 particles at different position on this two-dimensional coordinate system. The first particle M1 is placed at the origin, so its coordinate is 0, 0. Second particle M2 is placed on the x-axis, so its coordinate is 140, as the edge length of the equilateral triangle is 140 centimeters, so its coordinate is 140, 0. And the third particle is placed on the xy plane, and its coordinate is 70, 120, as these values are given the diagram in the table below. You see here you have 3 particles. These are their masses respectively, and their xy coordinates are given here. Now from our main lecture videos, you have already learned about the equation to find out the position of the center of mass of a system of particles. So here the center of mass for the system of 3 particles as shown in the diagram with a red dot, and this is a point, and we know that center of mass is a point where all of the mass of the system is concentrated. We actually consider this thing. So this center of mass, as it is a point, so it has 2 coordinates, as we consider a two-dimensional coordinate system to describe the center of mass for the system of 3 particles. Okay, so the center of mass, it has 2 coordinates, and these 2 coordinates we denote these 2 coordinates as x cum and y cum. These are the 2 coordinates, and we know equations to find out the x coordinate of the center of mass and the y coordinate of the center of mass. So if you consider the x coordinate of the center of mass, then the equation is x cum is equal to summation, it is I equal to 1 particle number 1 to particle number 3 mi xi divided by mi, here I is equal to 1 to 3. In the numerator, we get the product of mass and the x coordinates for each of the particles, each of the 3 particles here. And in the denominator, we have the sum of the mass of all particles. So what we get from this equation, we get this as, it is m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. So if we put the values here, then what do we get actually? If we put the values, then here you see that these values are, it is 1 point, it is 1.2 the mass of first particle, 2.5 mass of second particle, 3.4 mass of third particle, and here 1.2 multiplied with 0. This is the coordinate of the first particle, x coordinate of the first particle, and m2 is 2.5 multiplied with 140, x coordinate of the second particle, and it is 3.4 multiplied with 70, the x coordinate for the third particle. And what do we get from this? We get from all this that the uh, the center of x coordinate for the center of mass is equal to 83. It is 83 centimeter. So this is the x coordinate of the center of mass. It is 83 centimeter. Now we use the same equation for the y coordinate of the center of mass, and here this is I equal to 1, 2, 3 summation over mi, yi, and here summation I is equal to 1 to 3 mi. So we get the same form here. It is m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. Now if we put the values, then what we get, it is 1.2, it is 2.5, and m3 is equal to 3.4. Here 1.2 into 0, it is the y coordinate for the first particle, 0. 2.5 into 0, y coordinate of the second particle also 0, and here 3.4 multiplied with the y coordinate of the second particle, it is 120. So what do we get? We get from this as the coordinate, y coordinate of the center of mass is equal to 58 centimeter. So here the y coordinate of the center of mass, it is 58 centimeter. That means this is the center of mass, position of the center of mass, and its coordinate is 88, sorry, it is 83, it is 83, so it is 83 and 58. So this is the coordinate of this center of mass. Okay, and we can also express this center of mass in terms of a position vector, which we call RCOM. Okay, it is equal to 11 cm. Sorry, uh, it is it is 83 cmi plus 58 cmj. So it is the representation of the center of mass in terms of position vector, with its unit vectors. So in this two-way we can actually express or describe the center of mass of a system of number of particles. And here for this center, for these three particles, we can find out, we can express the center of mass by the coordinates and also by the position vectors for the center of mass. So now we'll move to the second problem, and in this problem what we see here, we have three uniform thin rods, and these rods are placed in such a way that these rods actually form a inverted U-shaped object. All these rods are continuous material, and for this continuous solid object we can find out the center of mass by using an equation which actually related to some integral form. So here suppose suppose here the position for the center of mass, suppose it is COM, it is the position of the center of mass for any uniform thin rod. Then we know an equation to find out the center of mass for a uniform thin rod, as it is a continuous material, so use here integral sign instead of summation sign. So here M, it is dm. This m and dm, these are actually coordinates, these are actually position. Okay, these are actually position in any space. So here for the horizontal rod, as it is aligned along the x-axis, you see in the diagram, so its center of mass can be shown by the x coordinate. Okay, and the center of mass for this vertical rods can also be shown by the y coordinates. Okay, so here the equation that I write here, this is a notation to find the position of the center of mass, where m is actually this m is actually a variable to indicate the direction or distance. Okay, or coordinate of in any space. Okay, in m direction, the position of the center of mass is m com here. And if we solve this problem, then what we get? We get that L by 2 should be the position of the center of mass for a uniform thin rod of length L. Okay, so now here for all these three uniform thin rods, their center of masses are at the midpoint. So we can show this center of masses by here by a point, dot point. It is the center of mass for the horizontal rod. Here is the center of mass for the vertical left rod. Here is the center of mass for the vertical right rod. And as we get the point, then we can express this point in terms of coordinates. Okay, it is L by 2 0 because x coordinate L by 2 and y coordinate 0, because here we actually consider that the left end of this horizontal rod is the origin for this two-dimensional coordinate system, and this horizontal rod aligned along the x-axis, and this vertical two rods actually aligned along y-axis. So here this is the coordinate of the horizontal rod, and here we can also write the coordinate of the left vertical rod is minus L by 2, and here it is L minus L by 2. So these are the coordinates of the center of masses for these three uniform thin rods. And when we get the center of mass, that means that we actually convert these three linear object into a point particle like object. That means all the masses of these three rods are concentrated at the center of masses. Okay, so now we have a system of 3 point particles. Okay, so for this 3 point particles we can also find out the center of mass. Okay, so the center of mass must have two coordinates as x coordinate and y coordinate, as we have done this thing in the previous problem. So we can find out the x coordinate of the center of mass for this three points. Okay, which are equivalent uh, for the uniform rods of length L equal to 22 centimeters. So here the center of mass x coordinate is, it is the sum of uh, the masses of the three rods. Here the horizontal rod is 42 gram and the perpendicular rods each have 14 gram. And here we know from the equation of the x coordinate of the center of mass, this 42 multiplied with L by 2, it is the x coordinate of the horizontal rod, plus 14 multiplied with 0, this is the x coordinate, the left perpendicular rod, and here it is 14 multiplied with minus, sorry, it is L, it is the x coordinate of the right perpendicular rod. So what do we get from this equation? We get here it is 70 and here it is 21L plus 14L. That means here it is 35 by 70L. So here it is actually 2. Okay, here is 2, and we can write this as L is equal to 22 centimeter divided by 2. That means it is 11 centimeter. Okay, 11 centimeters. So what we get? We get the x coordinate for the center of mass is equal to 11 centimeter. Okay, so this is the x coordinate. Similarly, we can find out the y coordinate of the center of mass. Okay, here it is 42 plus 14 plus 14. Here 42. For the horizontal rod, the y coordinate is 0 plus 14 multiplied with the y coordinate of the left vertical rod minus L by 2 plus 14 multiplied with the y coordinate of the right perpendicular rod, which is also L by 2. So what do we get here? We get 70. Here it is minus 7L, because here it is 7 minus 7 also minus 7. Okay, so actually we get minus 1470 L. So here it is 5, that means minus L is equal to 22 centimeter divided by 5 is equal to minus 4.4 centimeter. So what do we get actually? We get that the y coordinate of the center of mass is equal to minus 4.4 centimeter. Okay, so these are the actually answer that we want to find out from this problem 2 of part A, and here it is part B. That means the coordinate ordinate of the center of mass of the system of 3 uniform thin rod is 11 minus 4.4. So this is the coordinate. So where is the position? So the position is along the x-axis. This is 11 centimeter, and below 11 centimeter, if we move minus 4.4 centimeter, then suppose here this is the position of the center of mass. And what is this coordinate? Its coordinate is 11 minus 4.4. And we can also express this position in terms of a position vector. Suppose r, center of mass, is the position vector from the origin. Suppose if you draw a line here, if you draw a line, okay, if you draw a line here, if you draw a line, suppose if you draw this is r com vector. So this r com is equal to 11 cm, it is I unit vector, plus it's minus 4.4 cm j. So this is the expression in terms of position vector for the center of mass of this system of 3 uniform thin rod. Okay, now we'll move to the next problem. Here problem 3, and problem 3 is an interesting problem, and in this problem two particles are launched. Two particles are launched from the origin of a two-dimensional coordinate system x and y. Here you see it is x and here it is y. Two particles are launched from the origin, and particle 1 is moving along the x-axis and the x-axis on a surface which is frictionless and with a speed of 10 meter per second, and particle 2 is thrown, it is launched with an angle with the positive x-axis and with an initial velocity of 20 meter per second. But the thing is, interesting thing is here, particle 2 is always remain above the particle 1. That means particle 1 and particle 2 have the same horizontal component of velocity. Okay, and here in this problem we have to find out the maximum height attained by the center of mass, which is h max. Okay, we have to find out this maximum height attained by the center of mass, and also we have to find out the velocity of the center of mass and acceleration of the center of mass in part B and C. Okay, so here in this problem, what is interesting, the interesting thing is lies here. Always stay directly above particle 1. The particle 2 will always stay. Okay, so here we actually consider the thing that the velocity of particle 1, I want to show this velocity in vector form and in unit vector form. Suppose this is v1. So v1 is equal to it is v1 I, and it is 10 meter per second Okay, it is I, and v2 is the velocity, and this velocity is v2xi plus v2yj. Okay, the thing is this v2x, as particle 2 always remain above particle 1, then this v2x and v1 will be same. That means the magnitude of v1 and magnitude of v2x is equal to 10 meter per sec. This 10 meter per second. Okay, it is 10 meter per, it is 10 uh, 10 meter per second. Okay, now from this thing and from the information that as we have the value for v2, where velocity of the particle 2 is 20 meter per second, so you can find the initial vertical component of the velocity for particle 2. Okay, so here we can write this as v2 square is equal to v2x square plus v2y square. Okay, so what is v2y? v2y is equal to root over v2 square minus v2x square. That means it is here 20 square minus 10 square. That means it is root over 300 meter per second. This is v2y. Okay, this is the velocity, the vertical component of particle 2. Okay, so now using Newton's laws of motion and the equation of motion, here if we use this equation, which is v square is equal to u square plus 2igs. Okay, and if we consider the vertical component of velocity for particle 2, for particle for particle 2, okay, the velocity, final velocity at the maximum particle 2 at maximum height, okay, at maximum height y x, okay, this initial this final velocity will be 0. Okay, and the vertical component of the final velocity, the final uh, final velocity of the vertical, the final velocity of the vertical component becomes 0. So the equation becomes 0 is equal to, here the initial velocity of the vertical component for particle 2 is v2y is v2y v2y square v2y square minus twice g, it is y max. So what is y max? So what is y max is equal to v2y square divided by 2g. So v2, it is actually root over 300 square by 2 into 9.8 is equal to 15.3 meter. So y max, which is the maximum height attained by the particle 2 only, is 15.3 meter, but this is not actually the maximum height attained by the center of mass for these particles 1 and 2. Okay, now suppose here for this particular series, it is supposed at the maximum height. So suppose its x coordinate is x and y coordinate is now 15.3. It is at the maximum height, suppose this. Okay, so what is the coordinate for this particle 1? Its coordinates should be also x and 0 as it is on the x-axis. So these are the coordinates. So from this information, we can find out what we can find out. We can find out the x coordinate and y coordinate of the center of mass for these two particles. Okay, and here here it is x COM is equal to M1 plus M2. Okay, so M1 into X plus M2 into X. So the thing is X M1 plus M2 divided by M1 plus M2, cancel numerator denominator, and what do we get? We get the X coordinate of the center of mass is equal to X. Now what is the Y coordinate of the center of mass? Suppose it is here, if I consider here, so it is Y COM is equal to, now M1 plus M2. M1 its Y coordinate is 0, M2 its Y coordinate 15.3. Now the thing is, what is M1 plus M2? M1 is 5 gram and M2 is 3 gram, and here M2 is 3 into 15.3. So here it is the value is 5.73 meter. 5.73 meter. This is the Y coordinate of the center of mass. Okay, so the thing is, we get this Y coordinate of the center of mass when the particle 2 is its maximum height. So this Y coordinate of the center of mass should be the maximum height along the perpendicular direction for the center of mass. Then what can we consider? We consider that yes, this Y center of mass is actually the maximum height attained by the center of mass is equal to 5.73 meter. Okay, so this is the answer that we want to find out for part A in this problem 3. Okay, and you see one thing here, we actually I actually use here 5 and 3 and 3. These are actually in gram units, CGS unit, but as in the numerator and denominator we have grams, so this grams will cancel out, and it will actually not hamper the unit, required unit for the X coordinate and the Y coordinate for the center of masses. So here the center of mass maximum height attained is the center of mass Y coordinate of the center of mass. So here you get the required answer for part A from problem 3. Now for the other parts, we'll move to the next slide, and here we have to find out the velocity and acceleration in terms of unit vectors, and we know that the velocity of the center of mass, okay, it is expressed by this equation. Here it is m1, it is v1 vector plus m2 v2 vector. The thing is, if we express this as unit vector, so here it is m1 v1i plus m2, and here this v2xi plus v2yj. The thing is, when the particle 2 is its maximum height, then the second quantity, this quantity, will become 0. Okay, so we have only this m1 v1i plus m2 v2xi, but this v1 is equal to v2x. Okay, so here divided by m1 plus m1 plus m2. Okay, so what do we get actually? We get actually here that v1i. Okay, so this is equal to 10 meter per second. I is the velocity of the center of mass for the system of two particles. It is the answer of part B. Now for the acceleration of the center of mass, we know this equation ACOM. This is equal to m1 a1 acceleration of the first particle, m2 a2 acceleration of the second particle divided by mass of first particle plus mass of second particle. So here uh, so it is it is m2. So the thing is, the first particle has no acceleration because it is moving along the x-axis with speed 10 meter per second. The surface is frictionless, so its acceleration 0. And here the first term 0 in the numerator, and second term m2. The particle 2 has acceleration only in the downward direction, so it is g. It is g, and its direction is downward. Okay, so we should use here a negative sign, so minus g j in terms of unit vectors, m1 plus m2. So now I put these values here. M2 is equal to 3 multiplied with 9.8, and here it is 5 plus 3. So 3 is also gram, 5 plus 3 is equal to 8 grams, so gram will cancel, and here it is j unit vector. So finally what we get? We get this minus, we get this minus 3.68. It is 3.68 meter per second square j unit vector. This is the acceleration of the center of mass for this system of two particles, which is the answer of part C in this problem 3. So this is uh, part C answer, center of mass. Okay. So these are actually all about for this tutorial class, and thank you, and okay, see you in the next tutorial class. Okay.